second question is how likely is another ice age going to happen in the future, and is carbon dioxide the main cause of it?
Well, I think we can answer the first part of that question by saying there's almost certainly going to be another ice age sometime in the future, but it will not be in the immediate future. The fact that we are now causing global warming by producing more carbon dioxide into the atmosphere means that we're actually making it more difficult for another ice age to occur. But that is a temporary effect. And in the end, meaning maybe in a few 100,000 years' time, there will be another ice age, but not in 100,000 years. Now, carbon dioxide is not a cause of the ice age. Carbon dioxide is having an opposite effect, discouraging an ice age by causing the Earth to warm up. But the carbon dioxide which we have in the atmosphere at the present time is not just the natural carbon dioxide which it had before we started burning fossil fuels. We're adding to it in a quite dramatic way. So one thing, if we look at the next slide, I think we've got a slide here. This shows the temperatures and carbon dioxide content of the atmosphere as a function of time. You notice the crests, the high points of all these curves are all at about the same level, between 280 and 300 parts per million carbon dioxide. Now this is a record going back 400,000 years. There are 4 ice ages here. The low points are the ice ages, and the high points are the interglacials. The high spikes are the periods when the Earth was warmest. Now the temperature variation, you can see there's 2 curves there. I hope they're apparent to you. The dotted line is the temperature variation inferred from the isotopes in the ice on Antarctica. And the solid line is the carbon dioxide content of the atmosphere as measured by bubbles trapped in the ice. And the thing I want you to notice is that these peaks, these crests, are all about equal, all 280 to 300 parts per million. And similarly, the troughs at the bottom, between 180 and 200 parts per million, that's when the carbon dioxide was least in the atmosphere and the temperature was lowest. Now, what is happening? What is the cause and what is the effect? The fact that all the peaks are the same says that the system is exchanging carbon dioxide in such a way that the total remains constant. And as the temperature rises, so carbon dioxide is less soluble in the ocean. And there's more in the atmosphere as a consequence because it's rejected by the ocean. But as the Earth cools, so carbon dioxide dissolves more in the ocean, and then there's less carbon dioxide in the atmosphere. So the appearance of low temperatures when there's low carbon dioxide in the atmosphere doesn't mean that the low carbon dioxide is responsible for the low temperatures. And that if we put more carbon dioxide up, there'll be higher temperature. That's not the way it works. The temperatures vary and carbon dioxide follows because of its solubility in the ocean. Well, now, if we look at the next slide, I think we'll see comparing the peaks of the curve which you saw before, which were down below 300 parts per million, on the left hand of the top curve there, you see left hand 300 parts per million is at the bottom end. That is a record of the carbon dioxide content of the atmosphere measured in Hawaii, Mauna Loa. And the wiggly line is a seasonal thing. It's highs when carbon dioxide is rejected by the decaying vegetation. And the solid line The darker line is another parallel set of observations on Cape Grim, which is northwest tip of Tasmania. They differ slightly for a very good reason. Cape Grim and Mauna Loa are in opposite hemispheres. And most of the carbon dioxide which is being produced by fossil fuel burning is in the northern hemisphere. And it takes a little while to cross the equator. So Cape Grim shows a generally systematically lower carbon dioxide content than Mauna Loa. But now, look at the way that curve is rising. That is showing that as we go from 1958, in this case, to 2008 or 2010, carbon dioxide is systematically rising. That is the fossil fuel effect. And if you look at the magnitudes of the numbers, it's now past 400. That graph was drawn some years ago. It's still rising. And that curve is all completely above the curve on the last slide. The spikes were all below 300. So what we're saying now is, that bearing in mind the previous graph showed us the total carbon dioxide content of the atmosphere and ocean together is conserved, it remains constant, and it's simply exchanged between them according to temperature. Now we are adding carbon dioxide to the system by fossil fuel burning, and that means that this added carbon dioxide will stay there. Natural processes do not remove it, because the natural processes are keeping the total more or less constant, just exchanging between the atmosphere and the ocean. And now that is, I think, not generally understood, that we're dealing with a cause-effect relationship, which is the other way around from what most people think, that the carbon dioxide content of the atmosphere isn't the cause of global warming, it's a consequence of global warming. And we are now adding to that, but the process will take thousands of years to come to terms. And, in fact, it will not naturally get rid of itself and not be absorbed in the Earth for 1 million years. So we've got a global warming which we've introduced, which we haven't any way of stopping. All we can do is to slow it down, and it will be there for 1 million years. Well, that is perhaps a bit disconcerting, but it's best to place the way it is.
If you enjoyed this video or like connecting with great minds, like, share, subscribe, and don't forget to hit that notification bell so you don't miss our next one.